I think we can start. Right, we have covered one-dimensional and multi-dimensional arrays, but the arrays that we have covered, they are not dynamic. They are not dynamic in the sense that they have got fixed sizes or fixed capacities, right? So when you are defining the array, you can maybe define an array which can store maybe any number of elements or x number of elements, right? So you can only use these types of arrays when you know the number of elements in advance, right? And maybe when your array is not going to be growing or shrinking in size. At times you might be faced with a situation where you want to deal with the rather dynamic collection of elements, where the number of elements will be increasing or decreasing, or the structure will be shrinking and growing. So in such cases you need to use what are called dynamic arrays. And the dynamic arrays that we are going to talk about, they fall under what is called the Java collections framework, right? And by definition, a collection is just a container, or just a group of elements. It is just a group of elements. And these collections, they can be used to store, retrieve, and communicate aggregate data. If you look at maybe the arrays that we have covered, they are actually a collection of elements of the same type, right? So here we are saying, if we are talking about the Java collections framework, we also have a group of elements, and we also have some operations which you can actually apply on that single syntactic unit. And the collections framework is just a unified architecture for representing and manipulating collections. All collections framework contain the following. One, we have got what are called interfaces. An interface is just a special type of a class. It's a special type of a class, and it can be defined as a purely abstract abstract class. And an abstract class is a class which cannot be instantiated. You can't create objects out of an abstract class, right? If it's a purely abstract class, that's what we are referring to as what is an interface. And in most cases, you will not be having any methods with implementation. You'll be just having a method headers, right? And the methods can actually be implemented in subclasses. So we are saying an interface is just a special type of a class, and that class cannot be instantiated. It cannot be instantiated. You cannot say new, then you specify the name of the instance, like what you can do with an ordinary class, where you can say new scanner, or a new buffered reader, new input stream reader, right? Those are concrete classes with implementation. If it's an interface, it will be a class, but you can't instantiate that particular class. So apart from the interfaces, this collection framework, it also has the implementations, or it has classes with the concrete implementations, right? So we are saying we have got classes which cannot be instantiated. In most cases, those classes will not be having any methods which would have been implemented, but only method headers. But you can still have some other methods which are with implementation in those interfaces. Then we have got the classes with implementation, and then these classes are the ones that you instantiate to get objects. Then lastly, we'll be having algorithms, or just methods. These are just methods, right? So that's what you find in these collections. What are framework? What are some of the benefits? These are the benefits. Since you guys are literate, you can just go and read on your own about the benefits of using the collections framework, right? Then these are some of the interfaces, right? So we have got an interface which is called collection, right? An interface, I'm saying it's a special class, but this class cannot be instantiated. You can't create instances out of this one, out of this class, right? But you can actually declare variables of an interface. Because we said that a class, any class in Java is a data type. Just like an interface. An interface is also a data type. An interface is a data type. We have got these interfaces, collection. So you can actually declare a variable of type collection and say maybe collection, maybe C, or a collection, whatever variable you want. And these are other interfaces: set, list, queue, deck, sorted list. Then we also have these other interfaces: the map, the sorted map. Right? They are all interfaces. What we are saying is that you can't instantiate these special classes. You cannot say new collection, you get an error. You cannot say new set, new list, new queue, new sorted set, because they are interfaces, right? Then if you look at that diagram, we have that hierarchy of classes or hierarchy of interfaces, right? So from that diagram, it's clear that our collection is a superclass, right? And its subclasses are set, list, queue, deck, and sorted set, right? And sorted set is a subclass of what? Of set. And it's also a subset of what? Of collection. That's an inheritance what? Inheritance hierarchy. It is one of the concept in object-oriented programming which allow you to reuse existing what? Existing functionality, or allow you to use existing code, right? If there are any methods, because we've been saying that in a class you normally find two pieces of information. You have the state and the behavior. You have the state and the behavior, or you have the properties or attributes, and then you have the what? The methods, right? So if there are any methods which are public and defined in that collection what? Collection interface, we can actually use those what? Those methods, or we can actually use those properties which are defined in the what? In the superclass, as if they were defined in the subclasses, because of the inheritance what? Inheritance mechanism. Just like you, there are certain what? Certain traits, certain attributes or characteristics that you acquired from your parents, right? But there are also some instances where people begin to question, because you will be having certain other traits or properties or characteristics which are not maybe from what? From your parents. So in such cases, maybe right. So what we are basically saying is that each super class, it sort of factors out common functionality. It factors out common functionality, right? Then the subclasses, they can actually access or acquire that common functionality. And in addition to that, the subclasses can have what? They can have their own distinguishing what? Distinguishing features. Those traits that I talked about earlier on, where people begin to say, you now be having your own what? Distinct features, right? So I think that's all about what about the interfaces and that inheritance hierarchy. But each of these interfaces, it has got other subclasses with concrete implementation, because you can't have an application wherein you only have some interfaces only. You are supposed to have some classes with concrete implementation, right? You are supposed to have some classes with concrete implementation. I'm going to focus more on the subclass of this interface, the list interface. The list interface is a concrete subclass which is called array list. It is a concrete subclass which is called array list, right? So that's the one that we want to look at, and it allows us to create dynamic arrays. It allows us to create dynamic arrays which can grow and shrink in size. Right? So these are arrays. They can be of any type. You can have an array list of integers, an array list of doubles, an array list of strings, an array list of whatever data type. Right? But these array lists, they normally take elements which are objects. If you look at int, float, double, they are not objects, they are primitive types. So you cannot maybe directly store them in what in these structures, because they take what? They take objects. But there is maybe a workaround. Right, so let me maybe just show you how to define an array list, and then maybe talk about some of the methods that you can actually use which are in the array list class. And we are saying it is inheriting from the list what? The list interface. It is inheriting from the list interface. So let me maybe just delete this. Right. So what we are saying is you can actually declare a variable of any of those what? Any of those interfaces. I can say collection AL like this. Right? This collection is not defined in the standard java.lang package. It is not defined in the standard java.lang package. It is rather defined in the java.util package. It is defined in the java.util package. So you need to import what? You need to import that package. So I think it is imported all the other classes which, but I'm going to just leave them like that because I'm going to use some of those classes. But what I wanted to import was this one only, the second one, java.util.collection. So I can also define a variable of type what? Of any of these types: set, list, queue, deck, and sorted list. But I can't say new, for example, collection. I can't say new collection. I get an error. And the error message is cannot instantiate the type collection. Cannot instantiate type collection. Right? Because it's an interface. An interface cannot be instantiated. Right? But we can actually assign this AL to any of the subclasses of collection, to any of the subclasses of collection which has been implemented, like the array list. Right? So we can define again a variable of type what? List here. But we can't instantiate list. You get the same error because list is what? Is an interface. Because here we need first to want to import list. Sorry. Import. We need to import list first, which is in the java.util package again. But still we have got this error that it cannot instantiate what? It cannot instantiate type list because it's an interface. Right. So we are saying a list is a subclass of what? Of collection. And list is a subclass called array list. But that array list is concrete implementation. That is the one that we can actually instantiate. We can actually say new array list. Like this. You can say new, sorry, I've got two new here. Supposed to be equal, new array list. It is no longer what? It is no longer complaining, but there are some warnings where it's saying array list is a row type, references to generic type array list should be parameterized. So we need to parameterize what? This. By specifying the type of array list that we want to create. Do you want to create an array list of integers, doubles, floating point numbers, strings, or whatever? That's how you parameterize. Just specify the what? Specify the data type. So you just come here and then you use angle brackets and then you specify the what? The type of array list that you want to create. Maybe supposed to store strings, simply do that. Right? Then on this side you also do the same, string like that. But this one is optional on the right hand side. Right? Either the data type is optional, I can remove the data type completely, right, and remain with those angle brackets only, or I can remove the angle brackets. But it's usually better to maybe better to leave it like what? Like this. It improves readability. So that's how you parameterize what? You parameterize your array list. Because here we have been saying that by definition an array is a collection of what? Of related elements. Right? So here you need to specify the type of array list that you want to create. You want to create an array list of strings. Right? So in brackets you can put the capacity, or you can put another collection, or you can just leave it like that, which means it creates an empty what? An empty array list. Or I can specify the capacity and say I want it to hold 6 elements, or I don't specify, or I can have a collection what? A collection object here. I can pass another collection as an argument. Right? So we are going to leave it like that. And then we said this collection framework, it has interfaces, it has implementations, and it is algorithms. Right? Algorithms are just methods. Right? We have got methods which allow us to add elements to this array list. We have got the add method. That is the first method that we are going to invoke. Right? So we use that al, and then we say dot add. Or if I just say al dot, I get a list of other methods. If you are using maybe an intelligent ID, I have got add, and then it takes just a string, add, then int index, then the element, then I have add all. If you have got a collection, you can actually add all. Then clear if you want to delete. Contains, if you want to check if it contains a particular element, contains all. Equals, then for each, get. Right, these are some of the one. These are some of the methods. We have other methods like size is empty. We have remove, sort, and so on. right? We are not going to cover all the methods. I'm going to maybe just pick a few and then demonstrate how you can use those methods. So the first one is add. So we have now created an array, a dynamic array, which is an array list, right? We now want to add some elements into that into that structure. So we say al.add, then you specify the element that you want to add to the, but the element should be what? Of that type, string. Should be of that type. So I can now say, I can add a string here. I can add a string, right? There are various approaches that you can use. You can add a string like this, right? Or you can say al.add, then new string, then you specify the string. Let me maybe put some strings here. Right, then I can also declare a variable. Maybe s is equal to new string like that. Then I can say al.add s like that. So my list now has 3 elements. My list now has 3 elements. What happens if I say system.out.println al? Right? If I run that, we get that set. We get that set with the elements. We have got the set with the what? With the elements, right? Or I can use that loop. Well, this is a collection. I can use the advanced for loop. For then string colon al, then I iterate. Right? What if I want to add an element at a particular position, or after a particular after a particular element? I use add and then I specify the position. I can say al.add let me add, I already have Tom, but even if you duplicate elements, there is no any problem. There is no any problem. But this is how we've been adding what? Elements, by just doing that. But if you want to add it to a particular position, you specify the position. So far I have 3 elements. So if I want to add that element after maybe position 1, I put 1 there, then comma, like that. Right? Then I save and then I run. Sorry, it has added, but I need to print here so that you can see the output. I need to print. Right, so as you can see, I initially had that list with Tom, Joy, and Amon. Then I said here al.add 1. So I want to add after position 1. After so at position what? At position 1. So we had what? We had Tom, Joe. So then at position what? At position 1, that's where we had what? Joe. So Joe has been what? He has been pushed to the right, one place to the right, and we now have what? We now have that element after what? After the first what? The first element. So that's how we insert elements at precise what? At precise positions. What if I try to, here I've got how many elements? I have 4 elements. What if I try to so my positions are from position 1 up to position, sorry, position 0 up to position 3. What if I try to add an element, say at position 9? What happens? Huh? Right, you get that ordinary or common error. The index out of bounds exception. The index out of bounds exception, where it's saying index 9, the size is 4. So you can't have index what? Can't have index 9. So you need to be careful when you are dealing with what? With these arrays. Yes. What if after declaring here and say maybe we want to have maybe 11 elements, what happens if we specify the size here? Huh? He's saying if we specify the size in creating the array and then we try to what? To access that, sorry, to insert an element at position 9. Alright, we are still getting the same one, the same error. Well, these arrays are slightly different from the ordinary arrays. They are slightly different from the ordinary arrays. With the ordinary arrays, if you are specifying the size, it will create the array and then initialize it with what? With if it is string, maybe with now, if it is an integer with zeros, if it's double 0.0 and so on. Slightly different with what? With our array list here. Right, apart from the add method, we also have the size. So I can actually what? I can actually say a l dot what? Dot size, like that. Right, and then if I run, it gives me 4, which is the number of elements which are in my what? In my collection. That's the size. Then we also have what? We have the remove. If you want to remove a particular element, I can say al dot remove. After adding teacher, maybe I want to remove Tom, I can say al dot what? Remove. Then I specify the index of the element that I want to remove. Maybe I want to remove the one at position 0, right? Then after that, if I print the size, I expect it to be now having fewer elements, which is now 3, right? And it has actually removed what? Removed that element. Here we are printing, let me comment this out, or print maybe after I've removed the elements. Right, like that. Right, so it has now removed what? It has now removed the element at position 0. Initially, what did we have at position 0? We had Tom. So that Tom has been removed. So we can use the remove. We can use clear if you want to delete all the what. You can just say l dot clear if you want to delete all the elements. Size, add, contains, if you want to check if it contains a particular what? A particular element. So I can actually say system.out println al dot dot contains, right? What was the element that I added? S, right? I can maybe say contains S here, which is ammon. Just want to check whether it contains that ammon, right? It's saying true because ammon is what is inside that. We have other methods. You can just go and try try this method. If you just say L dot what, you have a lot of these other methods. Equals get, right? If you want to get an element in a particular position, I can actually declare a variable here, but the variable is supposed to be the same as the type of what the array list. I can declare a string here and say P is equal to a L dot what, dot get. Then I specify the index. I want to get the element at position what, at position maybe a 1. Then I store it in that string variable P, right? What is the problem with this statement? Right, so I can now print that what? I can now print that P or do whatever I want. So that's how you get what? You get elements. That's how you get elements. This used to retain what? In earlier versions, it used to retain an object of type what? An object of type object. If I maybe let me check what I'm saying. A L dot get. Right, yes, returning what? Just retaining the string. Right, so you don't need to what? Don't need to cast it. Just leave it like what? Leave it like that. Right, we were saying that numbers are not objects. This accepts what? Objects as elements. So if you want to insert maybe numbers, you need to use the wrapper classes for numbers. If it's an integer, use integer. This integer. Sorry, integer. Spelling. Use that integer, and then you also need to make sure that here also have what? We also have integer. Right. Then you can now add some what? You can now add some integers instead of strings. So here you can now add integers directly like that, or you can say new integer. Then you pass what? You pass an integer as an argument, like that, and so on. Then all these statements become, will generate some what? Some errors. Here you now need to say maybe int, and then you get that, and then you store it what? Store it in that variable. Right, I think that's all about dynamic. What dynamic? Yes. In a list, it's just you just print. Right, so we are saying we have got maybe I think we only have 2 elements. Let's maybe add some elements here. L dot add maybe 50, then L dot add 23, Right. So what he's saying is that if we just pass this this AL is an argument and then try to print this is the output that we get. Right. But he's saying we don't want the output to be presented like like that. You want to maybe have each number on a separate line. You can just use you can just use a loop. And just use a loop. 4. Here we are dealing with with integers. So I say integer. I don't have a variable called I, right? AL, right? Then I say system.out.print line. Then I will print each and every. Sorry. I hope I have not deleted something there. Then I say I. Done. Then I run. Then I have each and every element on a on a separate line. I think that's all about dynamic arrays. That's all about dynamic arrays. Right. What I now want maybe to do is within the few minutes that are left, I just want to talk a bit about that assignment, not assignment, the tutorial question. So what we are saying is that you are given you are given some Python scripts. We would want you to convert these Python scripts to Java programs. Hey, something is going on here. Right. I think this is the file that I have this is the file that I uploaded on CME. So what I want you to do is to convert these Python scripts into Java. It's very interesting. I think all the scripts, they are running and producing correct output. So what we want is a direct translation. I am not saying go and write an insertion sort or a quick sort algorithm. I'm saying translate. So if I copy maybe something like this, I hope it's not going to distort the indentation. Yeah. So if I copy and paste that. So what I want you to do is where we have def, that's a method a method that we are defining. In Java, if you want to define a method, this is how you define your method. You define your methods outside outside the main method. Either before the main method or after the main method. That's where you define your methods in Java, or functions. The syntax is you need to specify the access specifier or scope. Then after that, you need to specify the Specify the return type, and then you specify the Specify the name of the method. Right? So the return type can be the type of data that you want to retain or that you want to get from the function. It can be int, double, float, or whatever. Right? If it's not returning anything, the return type would be void. Then the name of name of the function. This is it's insertion sort. Right? So insertion sort is taking a list. A list is more or less an array in Java. It's taking a list which we are maybe equating to an array. So here maybe I can make it specific rather than generic, because we haven't covered other concepts. Maybe we can just make it specific such that maybe we can sort maybe integers only, or maybe doubles, or so I can put an array maybe of integers, maybe like that. So that's my list which I would want to sort. Right? Then what are the steps? Then I can maybe just add a comment here and then say def what, then I add that Python first statement. Right? Are we together? Right. Then after that I go back to my script. Then I check what's the next statement that we have there. I need to delete some of these spaces. I have a for loop which says for I in range 1, length list. Right, how do I write that for here we need to introduce a loop control variable, maybe int, maybe I or x or whatever, is equal to, here we are starting at what, at 1. We initialize it to 1. Then I is what? What's the range here? If we say range 1, 10, what would be the valid indices? 1 up to 9, right? So here, what should we say? Less than what? Length. How do we get the length of an array? Right, dot length, like that. Then this colon, this one rather, it marks the beginning of a block. So here in Java we use curly braces. So we have our opening, we don't need to indent. Right? Dot length. Oh, sorry, that statement is incomplete. We are supposed to update our right, like that. Then after this, the next statement, what we have, value is equal to list I. So we want to extract the, so I can just copy it like as is, even the next one, and then just declare the variables. Right, I paste those two. Value, this is of type what? Of type int. So I need to declare an integer variable value. Then it takes the valued position I. Then I terminate my statements with semicolons. Right, then I say int j is equal to I. Then I terminate with a semicolon. So this is not list, is what? IA. Right. Then what do we have? We now have that while loop. While j is greater than 0, and list j minus 1 greater than value. So maybe I can just copy that and then I modify it from, I paste it there. I need to put my curly braces first. Right, what do we need to change? And Java uses what? Double ampersand, list that value. This is no longer lists now. IA, sorry. Right, then inside the while loop, what do we have? Just to check. inside the while loop we have 3 statements. Just going to copy those statements as they are, and then I paste them. Right, these are the statements. Right, we just replace a list with the IA, then IA, sorry. Then here we system dot out dot print IA. In Java, if we say print IA, it's not going to give us the kind of output that we expect to get. So we need a workaround here. Because if we say print IA, it will give us an address. Unless if we use an array list, we can print straight away. But here we might need to introduce another loop and then iterate over the collection, and then we print. Right, so what we can do is we can say for what we want to print here, that's int. I can introduce another variable, maybe k IA, like this. Then I put this inside, then I print my k. Then maybe after printing I might want to leave maybe a tab space or another space, /t, like that. Then after that I have that statement, which is not going to change. What else? Outside the while loop but inside the for, we have got these 2 statements. Outside here we have got these 2 statements. This is IA, and print, I replace that statement. As you can see, you can just write, a very small program in Python, but in Java, you need tons and tons of statements for you to achieve the same thing. See what we now have. But in Python, it was just a very small program. Right, then after printing that, we need to terminate these statements with semicolons. Do we still have something? We are now left with maybe calling. This is where we are defining our list, and then we are now calling it. So you do that from the main program, so main method rather, and then after that you print. So I can copy these 3 statements to the main method, and then I delete that. Right, so I can now go to the main method, which is here. Right, then I declare an integer array, maybe like that. Then here I need to put this in curly braces. Right, then I call the method. Right, then I need to print. Right, for printing I'm going to copy that method which I have already defined, or I can simply say for int maybe w a list, then system dot out dot print w, then plus Then I maybe just add what? I just add tab space /t, right? Right here, the way that we are calling the method, how are we supposed to call the method? This method, we need to create an object of the test class. It's almost time up. Let me just quickly do this. So we need to create an object, right? I can maybe call it O is equal to new test, like that. Then I now say O dot insertion, like that. Or we could have declared it as a static method. If we declare it as a static method here, we just come here and then we say public static. If you declare it as a static method like that, when you are now calling, you don't need what? Don't need to create an object like that. You just say name of the class test dot, like that. Right, let me maybe run and see if it's giving us the correct output. I think we are getting some output. I don't know whether the list has been sorted. I think maybe we should look at the last numbers. What's the largest number in our set? 93, 77, 55, 17. I think it's working. But my elements are on one line. I think you just need to just have some print lines somewhere in your code. But otherwise, that's what we are expecting. It's fun, isn't it? Yes?
Yeah.